All right, now we're going to look at a probability example. So this is a game where the first player has an advantage of winning. First player has a chance of winning is 60%. And the first player continues to go first until they lose, and then the other player gets to go. So we've got Beam and Matt who are playing. So WN be the probability that Beam wins N rounds. So before I do this, I'm going to actually make a tree diagram so we can see what's happening. So in the first round, I've got a 60% chance that Beam wins. That means that it's a 40% chance that Matt wins. If Beam wins, he's the first player again. So he has a 60% chance of winning again. Matt has a 40% chance of winning. But if Matt won the first round, that means Matt's now the first player in the second round, and his probability of winning is 60%, which means Beam's probability of winning is 40%. So this set of branches is our second round. So the probability that Beam wins round 1, 60%. The probability that Beam wins round 2, well, he wins round 2 either here or here. So to get to this branch, I would have 0.6 squared. To get to this branch, I would have 0.4 squared. All right. So show WN satisfies this relationship. So we want a previous term relationship. Well, looking from above, the probability that Beam wins around, given that he's won the previous rounds, is going to be 0.6 times the probability he won the previous rounds, or 0.4 times the probability he lost. Well, losing is going to be 1 minus the probability that he won. And if I simplify this out, 0.6 times previous term minus 0.4, that's 0.2 times previous term, plus 0.4 as we wanted to show. All right, solve my recurrence relation. Well, notice that this is of the form that we looked at the very beginning, where we've got a times u sub n minus 1 plus a constant c. And what we saw before, so if we've got un equals a times un minus 1 plus c, then our un value is going to be equal to, and I copied this down earlier. Let's put it over on this side. So here's our formula that we had from before. Okay, so using this, I can find my general term. Whoops. All right, so we know that our WN, our a sub n minus 1, here our a value is 0.2. Our W1 value was 0.6. Our C value is 0.4 times. Our A value is 0.2, so I'm actually going to flip this around to be 1 minus 0.2 to the n minus 1 over 1 minus 0.2. Okay. So there's my general term. That tells me that my third term is going to be plug in 3. I'm going to let you do that yourself. Put it in your calculator. You should get 0.504. So here's my part C. All right, part D asks, what happens if they play a lot of times? So that's really asking what's going to happen to the limit of Wn as n goes to infinity. Well, as n goes to infinity, I'm going to end up with 0 times 0.6 because this is a exponential decay formula, plus 0.4 times 1 minus 0 over 0.8. So I'm going to end up with a half And the implication of this is that even though the first player had an advantage, if you play enough games, it evens out that both players have a 50% chance of winning.